Okay, here's a quick video on connecting databases and dashboards with Row64. So we've got a new API that makes this really easy through Python. So just go run pip install Row64 tools, and we've got a tool there to convert data frames to ramdb. So you can see here are the tools here. This is the help page for the pip install. Very easy and simple and straightforward. And all you have to do is just on your server, this could be local or global, just go pip install Row64 tools, hit enter, away it goes, it'll grab the latest version. We can test that out. We'll just run Python 3 here, and we'll go from Row64 tools, import ramdb. Ramdb is the tool to write to the Row64 dashboard. And then on the code side, it's just a matter of importing pandas from Row64 tools, getting your ramdb, and then we're going to go load a data frame. So typically you're going to load it from a database, but in this example we'll just make our own data frame, and we're just going to say build a data frame in pandas from data, and then we're going to save it from df to file from the data frame and give it the path. It's that easy. And just go run that, run our Python script. And there we go. If we look at our files, it's made the ramdb. Now, Row64, the dashboard, is running out of the live file folder, but you don't want to write there. So if you look at var ww live, you'll find all your source files there. What you want to do is write inside the loading folder, and then the server will copy it over when it's running. So if we look in live, we can see this is where all the tables that we're using in Row64, all the examples that come with it, are written. Now let's get it into the temp folder here, and we'll get it by saving our ramdb in the loading folder. So you see we've replicated the folder structure, and that'll know exactly where to place it when it copies it in. And this will allow you to manipulate things on the fly without restarting the server when you make changes. Okay, so when you look at the big picture, what you're going to want to do is grab your, using Row64 tools, grab snapshots, or when there are changes, grab the data, write them to ramdb. It could be on the same place as the Row64 server, somewhere else. And what it's going to do is create this high-performance virtual data set that Row64 can manipulate at great speeds. It's a little bit like Redis. It pulls it out of RAM, it does compute over top, and pulls that to the browser. So if you want some examples, of course, you can see we've got this database tool in Row64, these recipes. You can insert these and see our examples. There are literally millions of examples of loading from different database types up on the web, but we have that all here, and you can just go and write that on the server. Another trend we notice with a lot of users is people like to have a VM version of the server. They save their ramdbs, they save their .dash files, and then they just copy them to the cloud server. So that's like kind of like a GitHub workflow where you can work locally and make all your changes and test everything and then upload them to the big server. Okay, now let's look under the hood on how this is all working. ramdb is pretty interesting. If we go look at the format itself, like we're looking here, we can see there's this ByteStream .py. And the ByteStream is at this sort of byte level. It's a very general way. We'll be writing a lot of new tools using this. And this allows incredible speed, but then it's taking advantage of this cache using contiguous memory. So let's look at some of the benefits of contiguous memory. Okay, let's look first at non-contiguous memory. And you can see our bytes are different here. We're moving through an array of bytes and they don't line up. On the CPU, we've got a range of CPU memory from L1, it's small and fast, to RAM, which is slow and big. And then on the operating system side, we've got the relationship between RAM and the SSD. Now, cache prefetching, what that means is it's going to try and predict what the next byte is and pull it in advance and move it from slower memory up to faster memory. However, when memory is non-contiguous, it mostly gets it wrong. And there's a performance penalty, and you can see you end up going down the chain here, losing a lot of time. The operating system works in a similar manner with memory mapping, and this is called a virtual memory, and it moves between RAM and the SSD, and it has a similar penalty. Now, contiguous memory, on the other hand, is extremely fast. Cache prefetching grabs the next bytes, and it can guess correctly more often, and you can see it knows the sequence that's coming, it makes sense to it, it knows what's coming next, and it's often correct. So this improves the performance dramatically, and execution can be an order of magnitude faster, and you can see our execution is focusing on fast memory pools, and there's only a discontinuity between these contiguous strips. So we hope you found that install overview helpful, and we hope you enjoyed the video.